Hello. In this video, we will discuss graphs of equations. Um, we'll look at how do we sketch graphs of equations. We will look at finding x and y intercepts of graphs of equation. We'll also look at symmetry of graphs. And then finally, we will look at equations of circles and graphs. Okay? So we have seen before that you use a coordinate system to graph or to put a relationship between two quantities. And those two quantities that I'm referring to is the x, y point. So frequently, the relationship between two quantities is expressed as the equation of two variables. So, for example, if we have the equation y equals 7 minus 3x, this is an equation in x and y. Okay, so you'll notice that this here is an equation in x and y. An ordered pair where x can be some number and y can be some number will result in a true equation. So an ordered pair where x is equal to a and y is equal to b, okay, result in a true statement. And what I'm trying to say here is if we have the equation y equals 7 minus 3x, and if we look at x equals, let's say, 1, and y equals 4, then this here is true. Right? This would be a true statement. So if we do this, we have y. So this here, this is a true statement. And if we do this, y is equal to 7 minus 3 of x. If we take out the x and we take out the y, and we replace that with y is 4, so now we have 4 equals to 7 minus 3, and if we replace x with 1, then we will have 4 is equal to 7 minus 3, and we will have 4 equals 4, and this is true. So in this section, we'll review some more basic procedures, okay? And we'll look at the graphs of equation in the set of all points that are solution to the equation of all points. So this is just one point that we looked at that's on the graph. Now, if we're asked to determine, okay, so determine solution points. Okay. So if I give you a bunch of points, okay, So we want to determine if A 2, 13, B -1, -3, C 0, -7 are points on the graph. So we don't want you to do this by drawing the graph and then looking for, see if they fall on the graph. Okay, what we want to do is check them algebraically. So the first one, A, and I want to give you on the graph here, I should say, of y equals 10x minus 7. Okay, that's what we want to do. We want to determine that. So to do this, we will use algebra to check. We have y is equal to 10x minus 7, and the first point is 2, 13. So we have to recall that this is x and that's y. So instead of y, we're going to write 13 is equal to 10, and instead of x, we will write 2. So I'm getting that from x is 2, y is 13. Okay, and then we subtract 7. If we do this here, we have 13, sorry, is equal to 10 times 2 is 20 minus 7. So we have 13 is equal to 13, and this is true. Okay. So we can confirm, this confirms 213, okay, is a solution. That's our confirmation. That has confirmed that 213 is a solution. Meaning also that if we look on the graph, that point lies on the graph. So let's do the same thing now for part B. So we're going to use algebra to check. And then we have y is equal to mx minus 7. The point we are checking here now is in part B, -1, -3, right? Here's the point we're checking. So -1, -3. And remember that this is x and that's y. So instead of y, we're going to write -3 equals to 10. Instead of x, we will write -1, and then we subtract 7. So if we simplify this, we have -3 is equal to 10 times -1 is -10. Okay. -10 minus 7. -10 minus 7. So we have -3 is equal to -17. -17. So notice now this is false. So this tells us this is not a solution or point So -1, -3, okay, will not be on the graph. Okay? That's what it's saying. So this one here is false. This is not a solution on the graph. Not a solution. Yeah. And let's try part C now. Part C, we'll do the same thing. 0 minus 7. So use algebra to check. Okay. We have y is equal to 10x minus 7. And the point now is for part C is 0, -7. 0, -7. Okay. So we're doing the same procedure as we did here. So remember, this is x and this is y. So instead of y, we will write -7, and that is equal to 10. And instead of x, I'm going to write 0. And then we subtract the 7. So if I simplify this, I have -7. 10 times 0 is 0, -7. So we have -7 is equal to -7. And yes, this is true. Okay. So we can say that the point, which is 0, -7, is on the graph. This point is on the graph. So we can use this technique to plot points, okay, to create a graph. So the plotting point method, okay, or we can say first, we can use point plotting method or technique to draw graphs. So the method that we're referring to, the point plotting method, of graphs, of graphing. So we have these conditions. So the first thing is, when possible, isolate one of the variables. It doesn't matter which one, meaning leave x or leave y by itself. And 2, construct a table of values. So construct a table of values showing several x or y values. Only one. Make sure it's or, right? Or. And then use algebra to find the missing values. And we want to plot points on the table or from the table. And then finally, connect the points with a smooth curve. Or line. So those are the steps we can use to construct a graph. So this is just the table method, right? So let's look at an example. Sketch the graph. Sketch the graph of y equals, or let's do it where it's not in the form y equals 3x plus y is equal to 7. So notice my first step, when possible, isolate one of the variables. So for step 1, let's isolate one of the variables. And what this means is just to take the equation, okay, and leave either x or y by itself. So we see if we do this, we can have y is equal to minus 3x plus 7. Okay. So we isolated here, we have isolated y. Okay. So basically what we did, we subtract 3x on both sides. Okay. Now we can construct a table. So to construct a table, we'll create a table of values. So this is x, that's y. And we randomly choose some values. So we can say, let x be minus 3. Then we can have minus 1. We can have 0. We can have 1. We can have 2. We can choose 4. You don't have to go in sequential order. You are randomly choosing values. So these values are random values you choose. Okay, they are random values you choose. And then what we will do is find y. So for this case here, okay, to find the y value, to find the y value, to find y when x is equal to minus 3. So we have y is equal to minus 3, and then we plug in minus 3 for x. So minus 3 plus 7. And if we do this, this becomes y is equal to minus 3 times minus 3 is minus 9. Minus 9, okay? Minus 9 plus, no, minus 3 times minus 3 is positive 9. So this becomes 9 plus 7, which is 16. So here, the value you found is 16. Let's put this in red also. Okay. And we can continue doing this for all of these numbers. So y is equal to -3. Now I'm going to plug in -1. And if I simplify this, this becomes 3 plus 7. Okay? 3 plus 7, which is 10. So we have y is equal to 10. So we put a 10 here. Okay? And you can do this for all of the numbers. So y is equal to -3. Now we'll plug in when x is 0. So this becomes y is equal to 7. And that's 7, so this becomes 7. If we continue, y is equal to -3. And now I'm going to replace that with 1. So this becomes y is equal to -3 plus 7, and that's 4. So here we have 4. Okay? Y is equal to -3. Now we plug in 2. Plus 7. And that gave me y is equal to, when it's 2, we have 1. And then finally, y is equal to -3 times 4. So when it's 4, we have -12 plus 7 will give me -5. Need red. Okay. -3 times 4 is -12. -12 plus 7 is -5. So we write -5 here. Now, if we plot these points, okay, so now plot points. Okay. And the points we'll be plotting will be the first point where we have -3, 16. Then we have -1, 10. Then we have 0, 7. Then we have 1, 4. Then we have 2, 1. And 4, -5. Right? So those are the points, because each one of these is an ordered pair, right? Each one of these is an ordered pair. Okay? So if I make a graph and I plot these points now, you will see that I'm going to have a graph and I'm going to need a bigger space here. Because the y value goes up to 16 mostly, and I also have -5. So let's graph that over here. Hopefully this will work. Into the room. And for simplicity's sake, 2, 4, 6, 8, 10, 12 still doesn't work. Let's bring this down here, see if this will work. 2, 4, 6, 8, 10, 12, 14, 16, yes. So let's put multiples of 2's just so that we can have enough room to graph them. So here is -2, -4, and this will be -6 if I have to. And then here we have 2, 4, 6. Here we have -2, -4, -6. So the first point is -316. So -3 will be somewhere over here, and 16 will go all the way in the top. So that's my first point. My next point is -110. So -1 is going to be somewhere here, and that's going to be somewhere over there. Okay. So let's rewrite that 10. My point falls right on top of my number. Okay. Then we have 0, 7. So 0, 7 will be somewhere here. Okay. Then we have 1, 4. So 1 is here. So 4 is going to be somewhere there. Then we have 2, 1. 2 is here. 1 is going to be somewhere over here. This will be 1. Then we have 4 -5, which will be somewhere down here. Okay. So we know that this is linear. So if we now draw a line through these points, we should have a straight line, really. We should have a straight line. And this is the reason that I don't like using point plotting, because you have to be extremely neat. Yeah, extremely neat. So those points should actually fall on the graph. They are solution points. Okay? Each one of them is solution point. So for example, this here was the point -3, comma, no, +3, +3, comma, and we're getting that +4, sorry, +4, comma, -5, +4, comma, -5. This point here is 2, 1, okay, 2, 1. This point here is 1, 4. This point here is 0, should be 0, 7. So I have that written wrong. So no wonder my graph is slightly, this point here should have been 0, 7, which I messed up. This is 8. 7 would be somewhere here. Okay. 0, 7 and 1, 4 would be here. So let's see if we have a better graph now. If we have a better line, I should say. Looks better. Okay, looks better. So did I lose any point? I think we had a point 1, 4, right? 1, 4 we have. 2, 1. 2, 1 is here, right? 2, 1, somewhere there. So let's write them in now. So here we have 2, 1. This is the point 1, 4. This is the point 0, 7. This is the point -1, 10. Let's just make sure that that was the point, yes. And this is the point 3, 16. So just to show you where those points are, no more very important that when you graph the line, you must write the equation. So the anywhere, the equation of this line is y equals minus 3x plus 7. Or you could write 3x plus y equals 7, right? Either one of them. Either one. So you have to be very careful because there's a lot of things happening here, right? There's so many things happening. You have to be very careful to make sure that you don't miss a point or plot a point incorrectly. Okay, be very careful. Also, please make sure when you draw your XY axis, you label X and Y. Both of them must be labeled. So this technique can also be used for graphing equations of any type. The problem is that sometimes the points, when you connect them, are not very easy to see. So let's look at another example. Let's sketch the graph. So example, sketch the graph of y, let's put it over here, y squared, let's do an easier one first, y equals x squared minus 2. Okay. Let's look at that one. So in this scenario, y is already isolated. So y is equal to x squared minus 2. So notice y is already isolated. Okay? Y is already isolated. So we can make our table of values and we can fill in these values. So if we construct a table of value, okay, and if we have x and y, and for x values now I can choose minus 2, minus 1, 0, 1, and 2. Okay. And we'll do the same procedure as we did before. We have to find those missing y values. So in order to do this, we'll have y is equal to, instead of x, we'll now type in, well, first we want to, x is now minus 2, and we square that, okay? We square it, and then we subtract 2 from the quantity. So this becomes y is equal to 4 minus 2. So y is equal to, let's leave some room there, 4 minus 2. So y is equal to 2. So for minus 2, we have 2. Okay. And generally we write this in red, so we'll see that's the value we found. Okay. That's our value we found. We can do the same thing. So y is equal to now minus 1 squared, and then we subtract 2 from that. So this becomes y is equal to 1 minus 2, and that becomes y is equal to minus 1. So here we have minus 1. So this value is minus 1. If we continue, we have y is equal to, now instead of x, we write 0 squared and minus 2. So that becomes y is equal to 0 minus 2. So y is equal to minus 2. Then we try 1. So we have y is equal to 1. We square that, and we subtract 2 from it. So here we have y is equal to 1 minus 2. So y is equal to negative 1. And then the last value we'll plug in is y is equal to, we'll now plug in 2, so 2 squared and minus 2, so we have y is equal to 4 minus 2, so y is equal to 2. So now if we plot our points, right, the points we're plotting, our order points are minus 2, 2, minus 1, minus 1, minus 1, okay. 0, minus 2, 1, minus 1, and 2, comma 2. So those are the points we want to plot. Okay. So let's make a graph now. Let's make a graph. So here is my x-axis, and here is my y-axis. And since my y value only goes up to 2 and minus 2, I didn't need to make my graph this big. So we can move it up a little. Oh, that's the x. So here is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and here I have 1, 2, 3, minus 1, minus 2, minus 3. So the first point is minus 2, minus 2, positive 2, which is here. The second point is minus 1, which is there. The third point is 0, minus 2, then 1, minus 1, and then 2, comma 2, which is here. Now, if you notice, there is no way that I get a straight line. And that's why we said to connect them with a smooth curve. So if I draw a smooth curve here, it looks like I'm going to get a graph. Looks like that. And this here is, we know, is a parabola. So the equation here is y equals x squared minus 2. And you don't have to write them in, but I'm just writing them to confirm that I didn't make a mistake. This is 2, comma 2. This is 1, comma minus 1. This one here was 0, comma minus 2, because there is a point there hidden. Right? There is a point there. This one here is minus 1, minus 1. And this one here is minus 2, comma 2. So you will notice that when it is not a curve, that sometimes you have to plot a lot of points, too many points, as we'll see. And sometimes the points can be confusing, or you only get a piece of the graph. So we can see point plotting is straightforward, okay? It's straightforward. But it is long, okay? And it has shortcomings. it has shortcomings. Yeah. For instance, this will be seen, okay, with too few points. When we have too few points, it is not possible, okay? It is not, or it is not possible to see, okay, or misinterpret or misrepresent the graph. Okay? Equation. So this is very common, okay? Extremely common. So sometimes if you plot, so for example, if we plot the points -2, 2, okay, -1, -1, and 1, -1, and 2, 2. We can have three different graphs. So it's possible that when we plot this, we could have had a graph that looks like this. Okay. We could have actually, let's put in the numbers. Let's put in the numbers. So more. Let's do it here. So this is x and that's y. So 1, 2, -2, 1, 2. So -2, 2 can be here. -1, -1 can be here. Okay. Then 1, -1 is here, and 2, 2 is there. So notice here also, we could have thought a possibility is that maybe, just maybe, my graph looks like this. Okay, maybe. So that's a possibility. Okay. Or I could have done same thing. Okay, where you can see my graph could have possibly -1, -2. Okay. So this side is positive. So if we do the same point plotting technique again, -2, 2 is going to be up here. -1, -1 is going to be down here. 1, -1 is here, and 2, 2 is up here. Yes. So not 2, 2. 2, 2 is here. Now, it's possible that if we looked at this, And if I had drawn it neat, we could have got this one wouldn't be easy to draw, but I could have got sort of like a circle, right? Something that looks like a circle. So we could have got a nice circle. This should have been a circle. But because of my drawing scale, it's not. Okay, sort of like a circle. Or we could have got what we did, what we actually obtained above. We could have got what we obtained above, right? So because of this, it could lead to different graphs. So you have to be very careful. So 2, 2. Then my other point was -1, -1. Then 1, -1. And then this point here. Okay. So we could have got our nice parabolic shape as we did above. Okay. What was my equation? -2. So this should have come down to -2. So this is the problem. This is one of the problems that we see with these graphs, right? Where we said there are shortcomings to it. So some of the things that could help us here is, in addition to plotting points, right? So we know that this was the correct one, right? In addition to plotting points, we can look at some things like intercepts. So in addition to the table, we should find the intercepts. Okay. And remember, there are 2 types of intercepts, okay? Now some graphs, you will notice that some graphs, so note, graphs may or may not have X and Y intercepts. So for example, on the previous picture, we have where we had a scenario of both X and Y, right? So here we have X intercept. Here we got an X intercept again. Here we had a Y intercept. We can have graph with no intercept at all. We can have graphs with no intercept at all. such as here. Okay. Here we have no intercepts. Or we can have graph with only one intercept. Okay, we can have graph with only one intercept. An example of that could be this graph here, where it never crosses the x-axis. So here we only have y-intercept. Okay? No x-intercept. So various graph all depends on what you have, right? It all depends on the graph. So what is the condition? So finding intercepts. Finding intercepts. So to find x-intercept, let y equals 0 and solve for x. Okay. And to find y-intercept, let x equals 0 and solve for y. So those are the two conditions. Okay. So example, find the x and y, okay, x and y intercepts of the graph of, let's say, y equals x cubed minus 4x. Now you have to tell me which one you will find first, okay? So let's first find x-intercept. To find x-intercept, let y equals 0. So the equation, the given equation is y is equal to x cubed minus 4x. So we have x cubed minus 4x equals 0, right? We'll replace y with 0. Okay, y is equal to 0. Now we can factor this. GCF is equal to x. So if we take out x, we have x squared minus 4 equals 0. And then here you can factor this as x minus 2 times x plus 2. Don't forget this x comes down. So now we have x is equal to 0. We have x minus 2 is equal to 0. And we have x plus 2 is equal to 0. So this tells me x is equal to 0. This tells me x is equal to 2. This tells me x is equal to minus 2. So remember, intercepts are points, okay? Intercepts are points. So this one here, we get 0, 0. This one here, we get 2, 0. And then we have minus 2, 0. Okay? Y was equal to 0. And we got that from above here. Y is equal to 0. Yeah. So in this equation, we have 3 x-intercepts. Now to find y-intercept, okay, to find y-intercept, x equals 0. So our equation, y equals to x cubed minus 4x. Now if x is 0, okay, let x equal 0. So this leaves me with y is equal to 0 cubed minus 4 times 0. So we have y is equal to 0 minus 0. Y is equal to 0. So the point is 0, 0. Okay. 0, 0. So it will help. It will help. So if you put those now, if you put those points, if that's the x, and let's say somewhere here is y, okay, we now have 0, 0, okay, this is the point 0, 0, and our x-intercepts, we had 2, 0 and minus 2, 0. So 1, 2, 3. Let's say this is minus 1, minus 2. So this and this. Okay. So here, oops, minus 2, 0 here. Okay. So this is 2, 0. This is minus 2, 0. Now, if you make a table of values, if you made a table of values, okay, if we continue, so if we create a table of values, we can get a graph. Okay. We can get a graph. So if you do this, you will see that your graph should look something of this sort. You will see that your graph would look like that. So these are all possibilities of showing that the table method works, right? The table method will work. It just takes some time. It just takes time. That's all. It will work. Definitely it will work, right? So now let's look at symmetry, because symmetry is another way to help us, right? So now let's look at symmetry. So we want to now look at symmetry. So symmetry, right? Symmetry also helps us. So this is another tool that will help us to see a better picture of the graph. Now we can have symmetry. When we speak of symmetry, we can have 3 types of symmetry. Okay, 3 types. Those are, we will have what is called x-axis symmetry. An x-axis symmetry just means that the graph will reflect over the x-axis. So if we look at a graph, for example, here is the y-axis, here is the x-axis. If we look at the graph, let's say this one here. Okay. Make sure it goes through there. You will notice that if I have this point here, which is some x comma y, this point here is going to be some x comma minus y, right? So these 2 points are symmetric. They are the symmetry of each other. Some sort of symmetry. In addition, we can have y-axis symmetry. Y-axis symmetry. For y-axis symmetry, it means that the graph, okay, will reflect over the y-axis. And we've sort of seen this already, okay? We've seen this already where we had the graph that we drew before. We've seen that we can have a graph that looks like this, where this point here and this point here, so if this is some x comma y, this point here becomes minus x comma y. So notice that the x value change. Okay, so here we have y-axis symmetry. Okay. This one here was x-axis symmetry. And finally, we will talk about origin symmetry. Origin symmetry, likewise, is when the graph will reflect about the origin. The graph will reflect about the origin. Okay. An example of such graph, is this graph here. Okay. And you will notice that if I have this point over there, and let's draw a better graph. Let's draw a better graph. Okay. Now we'll notice that if this point here is x comma y, this point here is minus x comma minus y. Here what is called origin symmetry. Origin symmetry. So what are the conditions for a test for symmetry? Okay. So let's look at that now. Graphical test for symmetry. Graphical test for symmetry. So one, a graph symmetric with respect to x-axis if x comma y is on the graph and minus x, sorry, and positive x, because we're looking at x-axis. So positive x comma minus y is also on the graph. Okay? And we've seen that before, right? For x-axis symmetry. X-axis symmetry. So for x-axis symmetry in this picture, we saw that the y value is the one that changed. The y value changed, right? Negative. And that's what we're saying here. Y becomes minus y. Okay? And then we have the case where we have y-axis. So a graph is symmetric with respect to the, now we look at the y-axis. If x comma y, okay, is on the graph and minus x comma y is also on the graph. So notice here that the x value now changed, okay? And same thing for the picture. On the picture, x and minus x, okay? So we've seen that, right? And then we also have origin symmetry. Origin symmetry. So a graph is symmetric with respect to the origin x comma y is on the graph and minus x comma minus y is also on the graph. Yeah, it's also on the graph. So these are the three tests that you will have to perform if you're checking for symmetry. Yeah. Now a graph can have x symmetry, y-axis symmetry, origin symmetry. So how do we test? Okay, what's the algebraic test? So the algebra behind it The algebraic test for symmetry is the graph of an equation with respect to, let's do each one of them. So the graph of an equation is symmetric with respect to the x-axis when we replace y with minus y and we obtained an equivalent equation. So what it means is that if you have an equation, okay, and you take out the y and you put a minus y and you do algebra and you get back that same equation, then it is symmetric to the x-axis. Okay. Likewise, we can say the graph of an equation is symmetric with respect to the y-axis now. Okay. When replacing x with minus x, and we obtain an equivalent equation. Okay. And then the last one is the same, but we replace both x and y. So the graph of an equation is symmetric with respect to the origin when we replace x and y with minus x and minus y, and we obtain an equivalent equation. Okay. So those are the three tests we will have to really perform. Those are the three tests. Yeah. Those are the three tests. So let's look at an example. Okay. Let's look at an example. So, example. Let's test or check for symmetry. Okay. Check for symmetry with respect to both axes and the origin for the given function y equals 2x cubed. So generally, I don't have to say check for symmetry with respect to both axis and the origin. Generally, we just say check for symmetry. Okay. All we say is just, hey, check for symmetry. That's all. So we don't have to say that. So the first thing, remember there are 3 tests, right? So let's just test first for x-axis symmetry. Test for x-axis symmetry. And we know we must, okay, we must replace y with minus y. Okay, that's our goal. So if we do this, our original equation is y equals to 2x cubed. So if we replace y, we have minus y, okay, equals 2x cubed. Okay. And we notice that if we try to get y by itself, if we take this to that side, we end up with y is equal to minus 2x cubed. And this is not the same as the original equation. Okay? Therefore, we have no x-axis symmetry. For symmetry to exist, we must get exactly the same. Now let's test for y-axis symmetry. So test for y-axis symmetry. Okay. So for y-axis symmetry, we replace for y-axis symmetry. What did we do before? We did x-axis. For y-axis symmetry, replace x minus x. Okay. So remember, our equation is y is equal to 2x cubed. So we have y is equal to 2, and instead of x now I'll write minus x and cube it. And if I do this, this becomes 2. If we cube this is the same as x cubed, right? Minus x cubed, and there's a minus here, right? So notice that this here, this this is not the same as the original equation. So we have no x-axis symmetry. Okay? No x-axis symmetry. Okay? So now let's test for origin symmetry. Test for origin symmetry. If we test for origin symmetry, we replace x and y with minus x and minus y. So remember what my equation is, right? My equation is y is equal to 2x cubed. So now we replace y with minus y, and that is going to be equal to 2, but we replace x with minus x also. If we do this, we end up with minus y is equal to minus 2x cubed. So y is equal to 2x cubed. Okay? And notice that this here, this is the same as the original equation. So we have origin symmetry. There is only origin symmetry. So when you check for symmetry, unfortunately, it's 3 things you have to do, but it has to be done. It has to be done. And symmetry will help you with graphs, right? If you find that a graph has symmetry, okay, you will know what the graph sort of looks like, right? So for example, we now know that this graph has symmetry with respect to the origin. So if you graph just one part of it, okay, and that first part, if I graph, let's say, this part here, okay, we will see that if this is the point, let's say 1, 2, then on the other side of the graph, this point here will be minus 1, minus 2. So notice that they are a reflection sort of in the origin, right? If there is a mirror, there's a reflection in the origin. So that's where it helps. Now, the last thing we want to talk about is the equations of circles, right? Circles. Okay. Now, a circle is a set of xy points in a plane that is the same distance from R. Okay. So if you look at a circle, right? If I draw my circle here, we know that this here is the center. And the center we refer to H, Q. And if I have a point, let's say here, this is some point, X, Y, and this here is what we call the radius, r. R is the radius. So we refer to the center point as some h comma k. Okay? And the equation, okay, the equation of a circle is r is equal to, let's see if I can use a different color here. R is equal to the square root of x minus h squared plus y minus k squared. Okay, so that's just by from the distance. So by squaring each side of this equation, okay, if we square both sides of this equation, we also have the equation of a circle if centered at 0. So the standard form, okay, standard form, so that's the equation of a circle in general. But if we square both sides of this equation, okay, we get r squared is equal to x minus h squared plus y minus k squared. And this here is what we call the standard form. Standard form for or of the equation of the circle. So let's look at this here. Let's look at an example. Example. Suppose I ask you to the point 3, 4 lies on the graph or on a circle. I'm telling you now it is a circle whose center is at -1, 2. Okay. So we want to write the standard form of the equation. Okay, of this circle. So the point, so you're given a point. That point is 3, 4. That means this is x, that's y. Okay? And you're given the center, which is -1, 2. So this is h, that's k. Okay? So we know that r is equal to the square root, okay, of x minus h squared, okay, plus y minus k squared. So r is equal to the square root. And if we plug in those numbers now, instead of x, we write 3 minus h, which is a -1 squared, y, which is 4, minus k, which is 2, and we square that. Extend this line here. So here we have r is equal to the square root of 4 squared plus 2 squared. So r is equal to 16 plus 4. So r is equal to the square root of 20. And that's r. Now, we want the equation of the circle, so we only have r, okay? So now to find the equation, now find the equation, okay, we use, okay, x minus h squared plus y minus k squared is equal to r squared. And we know the center, so we have x minus, instead of h, we have a minus 1 squared. Y minus k, instead of k, we know it's 2 squared. And r is a square root of 20, but we squared it. Okay? So this is r. So finally we have x plus 1 squared, okay, plus y minus 2 squared is equal to 20. And here is the equation of the circle in standard form. Notice, so we can tell that the center is h comma k, which is equal to minus 1 comma 2 here, and r is equal to the square root of 20. So those are things you can tell by looking at the equation. Now we can also have many different applications to this, right? Many different applications. So what happens if I ask you to write the standard form? So let's look at another example. Write the standard form of the circle with center at origin. That means it's 0, 0, right? 0, 0. And with radius 3. So now what's given to you? Given here, r is equal to 3. So we have r, we don't have to find r. And the center is 0, 0. That means that this is h and this is k. So now by using the standard form, okay, formula, which is x minus h squared plus y minus k squared is equal to r squared. So we have x minus, instead of h, we have 0. Okay. Plus y minus, instead of k, that's also 0 because it's at the origin. That is equal to r, we know is 3. So replace r with 3. So if we do this, we have here x squared plus y squared is equal to 9. And this is the equation of our circle. Okay? This is the equation of our circle. So, as always, to master this, you will need a lot of examples and practice. So please make sure you practice as many examples as possible.